This is our lecture on correlation covering chapter 7 from your textbook. As your textbook does in every chapter, it starts off with some research that's relevant to the content of that chapter. In this case, we're talking about some research that was begun by a psychologist named Barry Schwartz in 2004, and then it was expanded upon a great deal by Iyengar and colleagues in 2006. Essentially, they developed a scale, or Barry Schwartz developed a scale called the maximization scale. You complete this by completing a very simple list of questions utilizing a Likert scale, and at the end, if you score, you're scoring 1 to 7, 1 being disagree completely and 7 being agree completely, so it's along a dimension from one end to the other. And then you add those response values together, and a score above 52 indicates that that individual is designated as a maximizer, and a score below 52 indicates that that student or that participant is a satisficer, which is a word sort of made up by Schwartz. What it really looks at is we're splitting people into a dichotomy of one or the other, which of course we know can always be a little problematic, but that's the cut score they've designated. Above 52, as I said, is a maximizer, and below is a satisficer. But essentially, what we're looking at in this chapter is about associations and correlations between variables. The research that Iyengar and colleagues expanded upon was really looking at people's score on this type of measurement, and then seeing how that correlated to future job satisfaction, decision-making processes, that kind of thing, and how that can influence happiness. So we're going to come back to this topic a few times as we discussed correlation throughout the chapter. So if you remember from our research toolkit or our toolbox, whichever metaphor you prefer, correlation and correlational research is one of the tools that we have. So essentially, correlational research is a widely used design of studies. It's also known as a relational study because you're talking about how variables are related to one another. It effectively addresses how these things are going to co-vary in one fashion or another, and if there's anything systematic about how they do so. It's a very simple design. It can be extremely simple. At its simplest level, it's really looking at just the relationship between two variables. For example, happiness and income. You're not necessarily saying anything about causation, so there's a really important aspect of correlation, which is that correlation does not mean causation. More famously, the phrase is correlation does not imply causality. Just because two things are related, it requires a further amount of evidence to make the argument that one causes the other. We'll talk a little bit about how correlational research tries to bridge that gap, but at its essence, what it's doing is just telling us how two variables are related. But you can think of the arrow between those two variables as having two heads on it. We're not really saying that one is causing the other. You can have more complex correlational designs. You can introduce more than two variables. Some of the research by Iyengar actually looks at some combinations of variables, including where you fall on that scale and how it relates to things like happiness and salary. So let's talk a little bit about that research for a moment, because I think it's a good example of correlational studies. The article that it was really spelled out in is from Current Directions in Psychological Science, and it was talking about looking for the best job and whether or not that actually undermines satisfaction, which is an interesting concept. So Iyengar and colleagues investigated 548 graduating college students. They gave them Schwartz's maximization scale, and they classified them into either maximizers or satisficers based on their results. So let me define those terms and what these things mean. A maximizer is someone who is always looking for the best choice. They're always investigating all possible options, pros and cons of whatever decision that they make. They're always looking for the excellent or the outstanding or the best possible choice. Satisficers are people who cross a threshold and are happy with a good choice. They don't really worry too much about making the absolute best choice. So in this case, that's how these students were designated, and then they were interviewed a year later and asked several questions about how their lives were going. The results were really interesting, and this is an example of how multiple variables, more than two variables, are correlated with one another. What they found was that maximizers, a year later after graduating college, were on average making 20% more in their annual salary. So on the one hand, maximizers seem to do better in that, at least in terms of salary. Of course, that's not the only way to sort of say whether or not someone is successful, right? But in terms of actual income, those maximizers did significantly better by about 20% of annual salary. However, they were also more pessimistic, they were more stressed, they were more tired, they were more worried, overwhelmed, and depressed. So the researchers concluded that considering so many choices had given the maximizers unrealistic expectations that led to negative emotion about their chosen job. Essentially, it made them always come back to the what if question of whether or not they had made the right choice. They were always second guessing that decision because it's very difficult to know if you made the best choice. As you know, in life, most choices have both pros and cons associated with them. It's very rare that there's one singular best choice. So this is an interesting example of correlational research that allows us to look at how variables are connected to one another, just in terms of their covariation. Going back to this last point, though, this idea that correlation does not mean causation. There's a comprehensive research review in your book discussed from 2005. And they noted that there was a strong association between happiness and success. This has been reported in several studies. And what it had led people to assume was that most investigators, they come to the conclusion that success makes people happy, right? And that is an example of taking a correlation and adding a causality or a directional relationship that you're imposing on it. It illuminates our tendency to overlook this bidirectional nature of a relationship, for example, between success and happiness, failing to really see how one affects the other. It also illustrates this study limitations of correlational evidence in testing a causal hypothesis. What it actually found was that happy people tended to be more successful. Subsequent research showed that the direction seemed to be more in that it was more that directional than the opposite. This idea that people that are starting out being happy tend to present themselves that way in life and tend to therefore be more successful. Based on a number of metrics, right? I don't want to overgeneralize too much, but it's an interesting example of where we can jump to a conclusion and look at correlational data and assume there's causality. So what is the sort of conceptual model we have at play in correlational research? So the principal objective of research, as we've talked about in the past, is to provide scientific understanding of the topic of investigation, right? There was four basic goals or objectives of science we talked about, and that was description, prediction, understanding, and control. So the correlational tool in the toolkit tends to focus more on the description and the explanation of the phenomenon. But really, because we're not talking about causality very much, we're probably more focused on description than explanation. So we have to start with that idea of a conceptual definition, right? We've discussed this in previous chapters. We take an abstract concept and we define it using other terms. And this allows us to build up a conceptual model of how variables are related to one another. For example, in the Iyengar study we've been discussing in this chapter, maximizer and satisficer, excuse me, that's a word made up by the researchers, right? Satisficer. These represent two key terms that require very clear conceptual definitions. Conceptually, they're two distinct choice-making strategies, and the researchers go into great detail in their conceptual definition. But the idea is that these two strategies for decision-making come into play in these types. The conceptual model that we develop, it really allows us to provide a theoretical foundation for our research, and a lot of theory building starts with correlational connections. So in that Iyengar study, the theory guiding their research is traced back to some early pioneering work by Herbert Simon in 1956 that really focused on maximizer and satisficer as two ways of viewing the world and really viewing the decision-making process. Theories that we utilize in psychology are sometimes embedded in what philosophers tend to refer to as nomological networks. This is where you sort of define a pattern of lawful relationships amongst concepts and variables, which you'll often see within studies that are developing or working from a nomological network are these figures of boxes with certain terms in them all connected to one another in various ways through various arrows. And these arrows have meaning in terms of what type of relationship you're describing. But a nomological network is how you can then go in with that conceptual framework in place, and you can actually test those relationships utilizing research. So the nomological network is sort of used to evaluate how good a theory is. It outlines how the concepts are related, and then you construct studies that actually test each of those connections between the variables and see how strong those connections are. It's also sometimes referred to as a nomological net, and it can be viewed as providing a framework to judge the validity of a theory. You know, it's like I'm saying that X is related to Y is related to Z, and that causes then some subsequent W thing to happen, right? What you can do with a nomological network or net is go in and show statistically through actual studies how those variables are related to one another, and therefore how likely is it that the theory itself is valid, meaning is it accurate? Does it really represent the way these concepts are related to one another? So as you can imagine, we come back to our old friends reliability and validity again. This is something that applies to all aspects of scientific research, and correlational research is no exception. So to examine the relationship between two or more variables, we need to make sure that we have reliable measures of each variable. We need to make sure that we're actually doing a good job reliably and validly and accurately measuring those variables. So Iyengar, in their research, they identified three key variables they were looking at: maximizing versus satisficing, like where do you fall on that scale; well-being, which is a measure of happiness, subjective well-being through a number of questions that are asked; and then finally salary, right, which is a variable that can be pretty easily operationally defined if you want to by the sheer gross amount of money that you make each year, or net, whatever, however you want to look at it. So as we know, these operational definitions, they flow from the conceptual definitions, and they indicate how we're going to code, measure, and quantify that construct, that concept. In the Iyengar study, again, I want to keep coming back to this example and utilize it to explore these things. They came up with this idea of the maximization scale, right? It's an objective score, and it ranges from a low of 13 to a high of 91. So if you rated each of the 13 statements as strongly agree, a 7 out of that 1 to 7 scale, then you end up with this score of 91. That's sort of the max. What they basically came up with is that they operationally defined the distinction between these two concepts, maximizer and satisficer, by what's called a cut score. They determined that 52 is essentially a good cut score for delineating these two types of people, or two types of decision-making approaches. So anybody below 52 is a maximizer, and anybody above 52 is a satisficer. I believe I have that. No, I'm sorry, I have it backwards. Satisficer less than 52, excuse me. Maximizer is a person with a score greater than 52. They utilized something in their research called item analysis in order to see if this scale, this maximizer versus satisficer scale, was reliable and valid. So item analysis allows you to sort of empirically demonstrate how the responses to each of the items of the scale discriminate between maximizers and satisficers. This is a specialized area of study within test construction. The idea being that you can not only say, does the person's overall score reflect, does it meet certain criterion, right? Can we show that it's meaningful through various measurements of other variables, things like discriminant and convergent validity, but does each item on the scale do a good job of also making that delineation? So you can actually go in through these methods and break down that scale of 13 questions, and you end up with some output statistically that tells you how discriminatory, or how good a job each item does of discriminating between maximizers and satisficers. So again, we're always coming back to the reliability and the validity of our measurements, of our theories, and of our design. The maximization scale, it is an excellent tool for measurement based upon their research, and it's a good way for testing this theory about the two decision-making strategies. It translates this theory, which is very conceptual. We're talking about an abstract reasoning process that each person goes through when they approach a decision in their life, and it provides very objective and operational criteria for distinguishing between these two types of people. An additional key task that they utilize is operationalizing other variables within this research. So I mentioned, of course, subjective well-being is sort of a psychological term for happiness, and how that's measured. Is that being done reliably and in a valid fashion? Income, of course, pretty straightforward, right? As we said, you just ask people what they earned. But correlational research like this, done by Iyengar and colleagues, it really offers important empirical evidence advancing our understanding of how things like your decision-making strategy is related to your success, to your happiness, to your well-being in various ways. And it's a good example of correlational research. They're not necessarily making the causal argument. They're just saying if one follows this pathway, then one tends to have these outcomes. We're not saying one causes the other necessarily. We're just saying that there's a relationship between them. So, as I mentioned, satisfaction, not as easy to operationalize as salary, right? They had participants respond to a list of 10 emotions. They had to rate each emotion on a scale of 1 to 10 related to how they felt about their job search process, and then averaged across these 10 emotions, creating this sort of composite score that they used as a general operational definition for satisfaction. So we're making choices along the way all the time in order to come up with an operational definition. There is a person whose name I always struggle to pronounce, a researcher, Lyubomirsky and colleagues in 2005, posited that correlational studies offer 3 classes of evidence that we can use to test conceptual models. Okay, so by utilizing this tool in the toolkit, these are 3 types of evidence we can derive that allow us to look at whether or not there's validity behind our model or our theory. And I'm going to go through each of these in detail. So the 3 types of evidence are descriptive evidence, inferential statistics, and longitudinal correlation. Let's talk about each. So descriptive evidence that we get from correlational research is really talking about the distribution of values of scores for a particular measure collected from a sample of research participants. So we're describing the data statistically with respect to 2 key characteristics that we're going to come back to quite a bit over the course of this class. Those are central tendency and variability. And these are basic statistical ideas that you need to be familiar with for this course, because a lot of the discussions we have about other types of inferential statistics rely on an understanding of these 2 things. So you've probably come across this in a math class or in a stats class or some other area of your life at some point. But let's talk about each of these in a little bit of detail. We describe data along these 2 sort of axes. Central tendency is computed as the mean, the median, or the mode. These are 3 different techniques for essentially talking about the central position for a set of data. And I won't go into great detail on each of these. We're going to talk about them more when we get down to our chapter on statistics. But essentially, let me just kind of give you the very quick and dirty version. The mean is what we traditionally refer to as the average, right? You add up all of the scores and then you divide by the number of scores, a simple average. The median is if I lay out all the scores numerically from highest to lowest, it would be the center score in that list. So it's another form of central tendency. It's not quite the same as average. There's reasons why we would choose one or the other. And finally, the mode is the most frequent response. So this is usually, the most common response that you get from the whole sample of participants. We'll talk later about why mean, median, and mode are different from one another and why sometimes it makes sense to use one over the other. But this is one of the ways in which we can describe data. We talk about central tendency. The other is to talk about the variability or the distribution of the numerical values. And we do this again in a few different ways that are interrelated. Range, variance, and standard deviation. These are just 3 statistical measures of variability that provide a quantitative number that sort of summarizes the spread of the variable, the numerical values for that given variable, how spread out are the variables. Range just gives you essentially the highest to the lowest. These scores range from 1 to 100, that kind of thing. And whereas standard deviation and variance are related statistics that show you the amount of variability within the data. So if you imagine the bell curve, sometimes the bell curve is very squat and very flat and the data is very spread out. Sometimes the bell curve is very narrow and very tall, where a lot of people are very close to the mean. So you need to understand the variability of data for a variety of reasons, but it does describe the sample in a really good way. Variance is a statistic that gets kicked out when you sort of look at how much each score varies from the mean. And then standard deviation is a usable number that's the square root of variance. Again, we're going to talk about this more in the quantitative statistics chapter. Don't get hung up on it. But I just want you to understand this is 2 ways in which we can describe data, is in terms of central tendency and variability. So just basic descriptive statistics, things like the mean, the median, the variance, the standard deviation, they allow us to compare the data that we have in our study with those of other empirical investigations. So it's very helpful not just in describing the data that you find, but for others that are going to do subsequent research or try and replicate findings, it helps them to be able to look at these types of descriptive statistics. So it plays a key role in the replication of results. But we don't draw conclusions really based on descriptive statistics. We're just defining what the data looks like. We're not really talking about connections between things very much. We don't test hypotheses with descriptive statistics. That is really in the grounds in the era of understanding and explanation, right? Which is a step down the ladder from where we are right now. We're really just, again, describing it, defining it. So we're not testing any hypotheses. And we can't really generalize to a wider population with descriptive statistics. We can only talk about the sample set that we have in front of us. So on the other hand, we do have inferential statistics, which is where we start to do hypothesis testing. What we're really saying is how do these groups differ from one another? So for example, if I'm doing kind of a classic psychotherapy clinical trial, right? I might have one group of people that receives my experimental therapy for depression, and I might have another group that receives no treatment but gets an antidepressant, or receives no treatment at all and they're just the control, gets measured at one point in time and then later again. You're sort of controlling for other compounds that just change over time sometimes, right, in the control group. Regardless, I'm going to be analyzing how those groups differ from one another. I want to be able to say, look, my treatment worked in terms of outcome compared to those that just got an antidepressant, those that got standard treatment, those that got no treatment. So what we're really trying to answer in this with inferential statistics is whether the differences between groups were due to chance or not, whether it's unlikely they were due to chance. And what we're really saying then on the flip side of that is whether or not these differences are what we call statistically significant. And we're going to get into this in a lot of detail as time goes on. But the long and short of it is, when we say that a relationship, a difference between groups that we discovered in our study is statistically significant, what we're saying is that it's very unlikely that that measurement, that difference we found is just due to chance, that I just happened to pull a sample where people got randomly assigned and it just turned out I found the relationship, but it was just due to error. It wasn't really there. So that's what we mean when we talk about something being unlikely to be due to chance. We often focus on statistically significant correlations in cross-sectional studies where we're looking at somebody at one point in time, where I'm going to measure one characteristic, one variable, and then I'm going to measure a second variable at the same time, and then I'm going to compare how those things are related through a correlation coefficient. So the correlation coefficient, when you hear that term, that's the actual statistical number, the actual stat that gets spit out by the test that tells us the degree of relationship between those variables, the strength of the relationship between those variables, and the direction. What it doesn't do, because it's cross-sectional, because it's just one point in time and no follow-up over time, nothing precedes anything else, it doesn't really tell us much about causality. From a basic logical perspective, remember, the cause must precede the effect in time, right? The cause can't come after the effect, otherwise it doesn't logically make sense. So in this case, when we're looking at these types of correlation coefficients between two variables or more than two variables, we're really looking at it at one point in time, and therefore we're just talking about how they're related right now. We're not talking about how they change over time or how they're associated one before the other. That question about how things precede one another is addressed through something called longitudinal correlation. So of course this is needed to address the sequence of events, to a certain extent. And this is the third type of evidence that we want to talk about in correlational research. So if one variable precedes another, then you can start to make the argument that it's predictive of the other. Now we're not necessarily saying causes yet, we're simply saying predictive. And in longitudinal correlational studies, ones that look at one point in time and then have a follow-up later down the road, that's what we mean by longitudinal, we can start to look at predictions. So going back to the example of the article for this chapter, the Iyengar et al. Research about maximizers versus satisficers and how it related to emotional satisfaction and job success 1 year later, or 6 months later in this case, they measured those students right before they graduated at one point in time and then followed up, I believe, 6 months and a year later. So there's a longitudinal correlation. Your score on the maximizer and satisficer scale back here before you graduated predicted in a relationship your job satisfaction, emotional satisfaction, your salary down the road. So there's a longitudinal stretch here between these two measurements, which allows you to say, look, one measurement precedes the other, therefore we can argue that maybe it predicts it. So we're getting into those other goals of science now. Now we're talking about prediction. So the Iyengar study really illustrates how a correlational study, even though it can't prove causality, it does provide compelling evidence based on the description of a concept and its empirical and theoretical links, connections, and associations based on its nomological network. It shows us how things are connected to one another through a variety of measurements and statistics, and by virtue of this longitudinal nature of the design, we see a predictive process. And so their whole theory about their nomological network, this that's based upon the theory of how there's differences amongst people in how they make decisions, how they process decisions, and that those differences in approach, those different decision-making processes, have different outcomes. They're predictive of different outcomes, at least. So this starts to address the why. We start to touch on the edges of causality, but we're really just talking about these things being connected in a statistical way. We're dipping our toe into causality without fully saying it, because as we'll see in the next chapter, you really need an experimental design to speak to show high internal validity and make a good argument for causation. Nevertheless, we are starting to address the why with these sorts of designs, even these correlational designs. And they utilize something called structural equation modeling, which is a statistical process. It's a somewhat complex statistical analysis that allows you to plug in all the different measurements, and it gives you some overall statistics, like something that's called goodness of fit. How well does my model, my whole network, fit onto the data? Does it fit well or does it fit poorly? So the statistical evidence that they found indicated that the emotional dissatisfaction experienced by maximizers was explained by feelings of regret that they had missed opportunities due to the large number of choices that they didn't pursue, right? The road not traveled, so to speak, in this case. It also offered compelling empirical evidence of a phenomenon first described by Schwartz, who developed the scale, called the tyranny of choice. For those of you that have ever tried to find something to watch on Netflix, you're familiar with the tyranny of choice, right? This is more choices or options one has to consider, the less happy one is. So there's this theory that was derived out of Schwartz's research, and it was supported by Iyengar's subsequent structural equation modeling, that says that the more choices or options one has to consider, the less happy one is, and maximizers tend to focus on all the choices, whereas satisficers just look for a good choice. So let's talk about the relationship between correlations and then confounds, right? Other factors that can be explanatory, that are, that are involved in whatever it is you're studying, and sometimes how we utilize control variables to deal with that. So correlational studies do rely on inferential statistics to analyze data results. It allows us to test a hypothesis about a population from sample data. So we're pretty much in the deep part of the scientific method now. It provides a technique to determine if the results can be generalized, and it tests a specific hypothesis to determine whether or not in this case, just two variables are related to one another. And it utilizes a statistical correlation coefficient. This is sometimes called Pearson's R. Pearson is one of the statisticians that developed this most common correlational statistic. And it's usually symbolized as a lowercase r, usually italicized lowercase r. So when you hear someone refer to the correlation coefficient, you will often see it represented by the lowercase r. As I said, Pearson's correlation, Pearson's R, is the most commonly used. It is only applicable to use Pearson's correlation coefficient on data that has a certain structure and appearance to it. The data has to be assumed to be normally distributed, right? It has to generally fit to that normal curve. If you apply this correlation coefficient to data that doesn't fit the normal curve, then it's not a valid, there's low statistical validity, right? It's not appropriate. So That's why we utilize things like those descriptive statistics first. You got to look at the data and see what's the mean, what's the median, what's the mode, what's the variability like? Is this data, does it fit a normal distribution? If it does, then I am then allowed to validly apply this type of correlation coefficient and see if this relationship holds between these variables. And of course, both variables have to be measured on a continuous scale. You can't do correlations with nominal or categorical variables. They need to be on a numerical scale that's continuous. There can't be like points or clicks where you're only one or the other. It needs to be along a continuous line, numerically speaking. What the correlation coefficient gives us is really three things. It teaches us three key pieces of information based on the statistic. It tells us statistical significance, right? So when you get that Pearson's R, when you open up your statistics package on your computer, for example, and utilize something like SPSS or SAS, or SAS, these are common statistical packages, and you have this set of data, all the scores that your participants did on one variable and on another, right? And then you plug all that in and you decide to run this statistical test. It's going to spit out three basic pieces of information. It will give you the actual the actual correlation coefficient. It's a number, an actual number that it gives you, which I'll talk about in 1 second. But it also gives you something called a p-value. Remember we talked about this idea of a p-value is really an indicator of statistical significance. But what the p-value tells you is, what is the likelihood that this relationship, this correlation between these variables that I'm seeing is due to chance? If that value is 5.05% or less, then we generally, that's kind of a goal. That's not, you can use 0.01, you can use other numbers, but generally 0.05 is a common one. If the relationship has a p-value of 0.05 or less, for example, then I would say, well, I think it's very unlikely this relationship that I'm seeing between these variables was due to chance. So that's the first thing it gives us, is a statistical significance test. It also gives you the actual correlation coefficient. Okay, correlation coefficients have a very limited structure. They are always between -1 and 1. So a correlation coefficient ranges from -1 all the way to 0 up to 1.00, right? So the closer the correlation is, the stronger the relationship between two variables. As one goes up, how much does the other go up or go down, right? In this case, reliably, systematically. How strong is the relationship between these variables? The closer you get to 1 or -1, the stronger the relationship. The closer you get to 0, the absence of a relationship. So the strength is the second thing, the second piece of information we get. For those of you that are familiar with the concept of absolute value from mathematics, right? It means you essentially get rid of any negative signs. You take the absolute value of the correlation coefficient, the number that it spits out between -1 and 1, however close it is to 1 of an absolute value of 1, the stronger it is. The closer it gets to 0, the weaker it is. So that's the second piece. The third piece is the direction. As I mentioned, it ranges from -1 to 1. A -1.00 correlation between two variables is an extremely strong negative correlation, meaning that as variable x goes up, variable y goes down in a very systematic and consistent way. So that's a negative correlation. A positive correlation would be as variable x goes up, variable y goes up at the same time. We're going to look at some scatter plots in a minute that help to address this. But basically, those are the things I want you to know about what the correlation coefficient is. And we'll talk a little bit more about confounds and control variables in a moment. So what is the nature of this association between two variables? We want to word our hypothesis as being predictive, as predicting an association between these variables, right? Usually as an if-then statement. Now, this is where I think things can be a little confusing, and I want to clarify something for a moment. Generally speaking, if we use the term independent and dependent variable, that is commonly associated with an experimental design. In a correlational study, we will sometimes just talk about variables, or correlates. And this is another term you can use. Because we're not talking about causal relationships in correlation very much, we tend to get away from independent and dependent variable. We're not manipulating the independent variable, which is one of the definitions of what an independent variable is, right? This is not an experiment. We're just measuring things as they are. And so the book can be a little confusing, I think, because it utilizes the terms independent and dependent variables, even when it's talking about correlational research. It might be better to think about them as correlates. However, when you are structuring a hypothesis, you are often implying, at least, if not straight out saying, that there is a causal relationship between one variable and another. And so we often see, even within correlational research, we often see our hypothesis worded as an if-then statement. If the independent variable increases or decreases, then the dependent variable increases or decreases. The if-then statement, the prediction, is only one of correlation, right? I'm only saying that these things are related in a strong correlation, positive or negative in this case. The nature of the association is also implied with the number of variables in the association statistic. So we often talk about bivariate correlations. A bivariate correlation is between only two variables at a time. So that's one thing to think about, is the idea that when we talk about correlation, the Pearson's R, the simplest form of correlation, is only two variables. However, there are ways, we're going to talk about in a moment, there are multivariate correlations that you can do. There are different types of statistical tests that allow you to look at the strength of the relationship between more than two variables. So that's something we'll come back to in a moment. We often talk about the relationship between two correlates, two variables that are correlated, as linear, right? I talked about positive or negative. What we're really talking about is a linear relationship between them, just whether or not it's negative or positive. But it's a statistical term about the nature of the association. It's describing the relationship of this direct proportionality between them, meaning that any given change in one of the variables or the independent variable will be accompanied by a corresponding change in the dependent variable. That's a linear relationship. As I said, it can be positive or negative. As one goes up, the other goes down is a negative relationship in a correlation, but it's still linear. Where we run into trouble sometimes with correlational research is that that's not always the way things are connected. Sometimes they are involved in what's called a curvilinear relationship. This is a statistical term that describes a relationship where the independent variable change either increases or decreases. There's an equal associated effect on the dependent variable, but it's not consistent, it's not linear. And I'm going to give you an example of this right now. There is a very famous study from 1908 by psychologists Robert Yerkes and John Dillingham Dodson, and they discovered something called the Yerkes-Dodson law, and it's really an example of a curvilinear relationship, and you've probably heard of this before at some point in your psychology classes. If you haven't, you will. What Yerkes and Dodson were looking at was how levels of arousal or stress. So in this case, when they say arousal, it's like how much is the mind activated, how much are you attending, how much energy is being put forth to whatever it is you're doing, right? So it's neither, arousal has a connotation related to physiological arousal, like sexual arousal. We're just talking about arousal, energetic level of brain activity might be one way to think about it, but also stress, right? Stress might be thought of as the negative other side of the coin of arousal. Anyway, Yerkes and Dodson were trying to look at the relationship between levels of arousal or stress and their association with how you perform on a task. What they found is that there was a curvilinear relationship. It's sometimes called the upside down U. If I can get my pointer here, I'm not sure if you guys can see this. It's essentially shaped like this. It's like an upside down U. And what you find in the Yerkes-Dodson law is that a medium amount of arousal is actually optimal. That performance tends to be worse if you have low levels of arousal or high levels of arousal, and that the sweet spot is somewhere in the middle. This is sometimes called the Goldilocks effect, right? If you remember Goldilocks and the Three Bears, she tries the porridge. One porridge is too hot, one porridge is too cold, the third porridge is just right. And then so on and so forth throughout the bear's house, right? But the idea is really fascinating because you can apply this very quickly to your own experience, thinking about a pending exam, right? If you have an exam coming up in a class and you are incredibly anxious and stressed about that exam and you're really worked up to study for it, and extremely stressed and aroused about this process, you will tend to do worse. On the one hand, if you have very low levels of arousal or stress, like I'm not even bothering to think about it, I'm not, you're likely to not study very hard, you're not going to pay much attention, you're going to have extremely low levels of stress or arousal associated with that performance, and you're also going to do poorly. The sweet spot is somewhere in the middle, right? A healthy amount of concern, a healthy amount of stress or arousal associated with that test. And that's what the Yerkes-Dodson law says. It's given here as an example of a curvilinear relationship, which would not be picked up by a traditional correlational statistic because it's not a linear relationship. So that was the point I'm trying to make, is that correlational statistics really only tell us about variables that are related in a linear fashion. It can miss things like curvilinear relationships. The way you detect these kind of things is through what are called scatter plots, and we've actually looked at one of these examples before. But a scatter plot is a visual representation of a correlational study that allows you to quickly look at it and note the nature of the relationship. You simply take each individual, each participant's score, and you plot them on an X and a Y axis, and you look at the overall relationship of the data points. So here are some examples of scatter plots. Now, going back to the curvilinear relationship. So what you would see in the Yerkes-Dodson is essentially, let's see if I believe I can, is something shaped like this. Okay. Yeah, let me just kind of reiterate that. So that's the Yerkes-Dodson, which is that over here would be the low level of arousal. Over here would be the high level of arousal. Performance goes down, performance goes down, performance is optimal somewhere right here in the middle. So that's an example of a curvilinear relationship, but let's look at these here for a moment. Let me erase that. So this is a positive correlation. As you can see, you plot the person's score on X and Y, whatever these variables happen to be. And you notice that as you score low on variable X, you also score low on variable Y. As you score high on variable X, you also score high on variable Y. This is a nice tight line of correlation here. This would be a very strong, like a 0.80, 0.90 positive correlation. Okay. Remember, that number tells us the strength and the direction of the relationship. Because it's very close to 1.0, that's the strongest positive correlation. We know that it's a strong relationship and that it's a positive one. That's the direction. This is the exact opposite. This is an example of a very strong negative correlation. If you notice here, as you score high on X, you score low on Y. As you score low on X, you score high on Y. As one goes up, the other goes down, and it hangs very nicely along this negative correlation line here. You might think of if going back to geometry, the slope of the line is really what we're talking about. This last one is an example of no correlation. This is a scatter plot where everything appears random. You have examples of someone that scores low on X, low on X and low on Y, but also someone that scores low on X and high on Y, and vice versa. So if you saw a data like this, you would think these variables have a very weak correlation. This is probably approaching something like 0. And then here is the Yerkes-Dodson curve. I knew this was in here somewhere, so we don't have to rely on my poor ability to draw on the screen. But this is the inverted U shape that's associated with low under-aroused, high over-aroused, poor performance. Maximum performance is here somewhere in the middle with that moderate or optimal arousal. Okay, so this is an example of the hypotheses that you might have within the Iyengar research. These are just some examples of what they would look like. So as I said, they are using the term independent and dependent variable because of the nature of the hypothesis. It is an if-then statement you're proceeding, okay? So the original hypothesis might be thought of: maximizers will have higher salaries. The independent variable in this case would be maximizer satisficer, where they fall on the scale, and the dependent variable would be salary. If you want to phrase it as an if-then statement, if maximizing increases, then salary increases. This would be a positive correlation that's being predicted by that hypothesis. Another example: maximizers will have lower levels of well-being. Again, the independent variable is the maximizer satisficer. The dependent variable is that measurement of well-being. As an if-then statement, if maximizing increases, then well-being decreases. Again, this is a negative correlation being predicted. Let's look at a few other examples. SAT and high school grades predict college and GPA. The independent variable would be your SAT scores, your high school grades. The dependent variable will be your college GPA. If high grades and SATs, then GPAs are higher. Again, a positive direction of association. And then finally, we have the Yerkes-Dodson, right? This is the curvilinear relationship where lower performance for high and low anxiety scores. The independent variable, excuse me, is your level of anxiety, arousal, stress, whatever you want to call it. And then the dependent variable is performance, and it describes it in terms of the curvilinear relationship. If too high or too low anxiety, then performance declines. So let's talk a little bit about, I mentioned there were confounds and control variables were a factor in correlational research as well, and this is where we kind of get into that. There is a common set of terms you're going to see in statistics quite a bit, moderators and mediators. These are essentially third variables that have an impact on the relationship between the two primary variables of interest. So mediating variables are really used to address the question of how and why. They are showing you the step between the two things. They're showing you the mechanics of the relationship between X and Y in this case. For example, in a clinical intervention, let's say that I have this, my independent variable is whether or not you receive my new therapy for depression. My dependent variable is your score 6 months later on a scale of depression, the outcome. The mediating variable might be the theoretical process that's happening in between. So let's say that my particular treatment for depression is targeting self-efficacy and self-confidence, and therefore it's the intervention affects self-efficacy and confidence. That's the mediating variable, and that results in a more positive outcome in terms of less depression. Moderating variables are a little different, but they're associated with a set of research questions that talks about the circumstances or the conditions that need to be in place that strengthen or weaken the influence of the independent variable on the dependent variable. So the moderating variable is not explaining what that black box process in between the independent and dependent variable is, but it is talking about how that relationship can be sort of maximized or minimized depending upon a third variable. So for intervention outcome research, it talks a lot about it asks groups for which groups of intervention may have maximal effect. So it might be that, like, my therapy works for people that have a certain type of depression, and that's the moderating variable in play. For correlational research, the question about the strength of the relationships between independent and dependent variables across different groups and conditions is sometimes explained by identifying mediators or moderators. Give an example of this from the Iyengar research. There was some follow-up replication that was done by a group by Rotz et al. In 2012, and they found that the negative effect of maximizing on well-being holds across different cultures, but that there is a moderating effect for culture. So basically what they found was that within certain cultures, this decision-making process had a stronger or weaker, depending on the culture, impact on well-being. So that's an example of a moderating variable. This is the example from the book. What you see, this is the culture as a moderating variable on the influence. Sorry, let me turn my phone off. The strength of the relationship between regret and maximizing. So what they find is that in Europe and in the US, and in China, this relationship still holds. You notice that the slope of the line is somewhat similar, but do you notice that these two lines here are significantly distant from this line, right? And this line is an example of the one in China. So what they found was that Chinese culture, presumably in some way or another, was moderating the strength of this relationship. So you essentially saw higher levels of regret consistently, regardless of whether or not you're a satisficer or a maximizer. Culture was amplifying this relationship to some degree. So these are all third variable effects, right? Mediators and moderators are ones that we can identify, called third variables. But third variables, those are ones we measure, that we try to understand and we include in our analysis. But there's always the problem of confounds. Those are variables we haven't thought of, or we haven't measured, or we haven't identified, and they can act to confound the relationship between our variables. a confound is related to both the independent and dependent variable in some way. And a failure to adjust or control for that confounding variable can create really serious problems in how you interpret the results of your study. Without controlling for confounds, it messes with your data interpretation, right? It can lead you down paths that are not accurate. It can lead to erroneous conclusions about the relationship between the independent and dependent variable. So confound variables are notorious for leading to what are called spurious or erroneous correlations. A spurious relationship is basically when there's a correlation between two variables that's caused by something other than the effect of the presumed relationship between the two. There's something else going on in there that's actually the prime mover that causes the relationship. Researchers have found a statistical correlation between ice cream consumption and murder rate, but clearly one does not cause the other, right? So there's a spurious relationship there. We don't know why those two things happen to be correlated. A third variable can also be used to offer an alternative theoretical explanation for the how and why between the independent variable and the dependent variable. So the goal is to rule out alternative explanations by including a control variable in your analysis. This additional variable being measured and being incorporated into the statistical tests allows you to reliably and validly measure how much influence that third variable, that confound, has. By controlling it, by measuring it, you're accounting for it. And in a sense, you're defending yourself from criticism later when someone examines your study and looks for mistakes that were made in the scientific method. So the last part of this chapter is somewhat unrelated to correlational research. It's included because it needs to be here somewhere in the book. I do sometimes feel like the authors kind of arbitrarily decided to put it here, but it is an important thing we need to talk about. So we're going to shift gears a little dramatically here and talk about, in general, about the rules of psychological writing for a moment. So they use an example in your book of the decision-making strategies in a college student sample. They show you sort of the process of how this relates to psychological writing. Now, the APA style manual, the publication manual, which we're going to talk about in chapter 12, this is a gold standard for scientific writing in psychology. This is a book that I actually have as a recommended text on the syllabus. If you are a psychology major, especially if you're considering graduate school, it's worth your while. There was a new edition that came out recently in the last couple of years. But really, it is the book that articulates and lays out all the principles for clarity, concise wording, and accuracy in writing in psychology. It talks about facilitating the flow of communication from the author to the reader, so keeping that communication clear and understandable. It shows you how to produce a scholarly paper that describes and explains psychological concepts in terms of evidence and the results of that empirical evidence. And it uses in its literature review, remember we talked about the introduction of a research article is essentially a small literature review. It uses primary sources. Again, remember primary sources are peer-reviewed reputable journals. It uses those primary sources to then build your argument for the research that you are going to then describe. It gives context. It provides a roadmap for how we're getting from point A to point B. In a review article, it's really just an empirical review of a lot of different journal articles and talks about how other empirical studies support a particular argument or theory. For a research article, aka an empirical article, the evaluation is more directly targeted to specific elements of your reported study. You talk about the theoretical rationale, the hypothesis, the methodology, the statistical analysis, and the conclusions. These are all going back and standing on the shoulders of giants, right? Building upon the body of knowledge that's already there to justify the validity of the study that you are then conducting. So when you're writing an empirical article, it has a certain organization and structure. And this allows for clarity for the reader. It also allows a roadmap for the author in how the article should be structured. Virtually every psychological journal article you read is that is a research study report. An article based on a singular or group of studies is going to follow this structure. So we'll talk about each of these in a little bit of detail. You have an abstract, an introduction, a methods section, a results section, and a discussion. Very briefly, the abstract, as I've mentioned, is a short 140-word summary of the entire study. So everything you see in this list from abstract to discussion, there's going to be a sentence or two in the abstract that touches on all these major points. It's just a summary, right? It's a block summary of the whole thing. You then go into your introduction, which is really starting with a broad review of prior literature. It then narrows into the rationale for your study and gives framework to the concepts, terms, and theories that you're including. The methods really details the operations and the procedures used. It tells you how you conducted the study in great detail. It's usually broken into 3 sections: sample, measures, and procedures. Sometimes sample is called participants. Measures is sometimes called instruments or apparatus or whatever, but essentially this is the 3 basic parts of a methods section. You talk about the sample and how you went about getting your sample from the population, the processes that you used for random assignment, all that stuff, what measures you're using, which is again partially a discussion of how you're operationalizing the more abstract conceptual terms that you're studying. But I used this, you might describe, I used this particular, the Patient Health Questionnaire 9 to measure depression. This is what the PHQ-9 is. This is how it has validity and reliability based upon previous research. I also measured people's subjective well-being via this measure, so what actual techniques did you use? And then finally, the procedure is, what did you do in the study? So like in the Milgram study, for example, the procedure is where he walks through the whole process of how you introduce the confederate and do the fake random assignment to being the teacher or the learner, the description of the apparatus, the shock generator, the whole process with the experimenter giving the prompts, the cues to continue. That's all part of the procedure. The results is where you talk about the actual statistical outcome of the study. So results is still concrete, right? It's talking about operational outcomes, actual numbers and data and statistics. What you're really reporting in the results is, we ran this analysis and we found this. You're not really getting into what it means conceptually at all, because that happens in the next section, which is the discussion. So in the discussion, you talk about the implications of those results, what they mean in terms of interpretation as it relates back to concepts and constructs. You also do things like review limitations of the study, places where it fell short or could have done better. And then you talk about how it has, how you can apply the findings to the current understanding of the field, and then how it can lead to further research, how this particular study, can then be built upon and replicated and developed by subsequent research of one form or another. This is the hourglass shape that the research report takes. So when you think about those 5 basic parts I just described, what your paper essentially should do in a psychological article or a journal article is it starts very broad. All right, this is the fat part of the hourglass here. The introduction and the literature review tends to be very focused on the idea of like, what's the overall larger theoretical understanding in the field about these constructs, right? You start, again, very broad. You want to start conceptually, okay? And then you narrow and you become more specific, more operational, until you get to sort of this narrow belt in the middle here, which is really where you're really talking about your specific study or studies, your specific methods, and your results. Once you reach the discussion, though, you start to interpret those specific results and talk about how they relate to the larger constructs at hand, how it comes back to theory, right? We go theory, data, theory, so to speak. We start up here talking about a lot of theory, we get down to some hard data, and then we try to go from deduction back to induction, right? From data back to theory implications and how it relates back to the larger context, which was established here in the literature review. So this is just a little visual device to help you think about how you structure a traditional psychology article. This is from your book, but this gives you sort of examples of all of these parts. What they do here is on the left column, what you see is some prompts for what it is that's happening, and then it gives you some quotes and examples over here on the right. I'll allow you to look at this in your book at your leisure, but this is a really good breakdown of what an article feels like, how it makes these various turns throughout that hourglass structure. So finally, I want to talk about a few conclusions that we should come to regarding correlation. The first and probably the biggest takeaway from this is that correlation is not causation. This is a critical thing I want you to understand about correlation. We know that a correlation can exist, but the primary variables, we can't make the argument that they necessarily or directly cause one another. Correlation studies do provide us with very reliable and valid evidence for examining research questions, testing research hypotheses, and talking about how variables are related to one another in a systematic way. Although there are limitations to correlational studies, these studies reveal things like moderating and mediating variables that exist, and they allow us to flesh out conceptual models and sort of fill in the blanks on the relationships between things and how they're connected to one another, what the process is of how those things are related to one another, why they covary, for example. And this takes the form of descriptive and inferential statistics that start to give us an explanation of why and how our variables are related to one another within our topic question. Often the major findings assist in prediction and generalization back to a larger population despite not being able to always argue for causality. So correlational research is an important tool in the toolkit, and we're going to talk next about experimental study in the subsequent chapter.